Uh, it's time to do the problem of March 8. Let me refresh. Okay, it's available now. It's an easy problem. You are given a zero index string blocks of length n, where blocks of I is either W or B, representing the color of the ith block. The characters W and P remains black and white. White and black. Okay, you are also given an integer k, which is desired number of consecutive black blocks. In one operation, you can recolor a white block such that it becomes a black block. Uh, in one operation, you can recolor a white block such that it becomes a black block. Return the minimum number of operations needed such that there is at least one occurrence of k consecutive black blocks. So I need a consecutive box of color black, and the length of the block needs to be at least k. So there's a problem. Uh, Let me see how I can solve it. So if if I color it as 1 and this as 0, sorry, not color is like if I 1 1 0 0, if I give numbers, so 1 1 0 1 0, and then I try to add them. If I try to add them, then what? 3, I prefix sum. So I'm just saying if I can make it work somehow. My idea is to somehow get the maximum possible length there is available till now. So 4 minus 4 minus 1. So the length of this is 1 2 3 4 5 6 7 8 9. 9, and so 9, and here I have 5 blacks, as 4 minus 1 plus 1 is 5, and the length of this sequence is 9. That means I am having 4 colors in between, which are white and needs to be colored. I can make a brute force solution, but I don't want to do that. I want to find a O of n solution. So how can I do O of n solution? Hmm. So if I start from here, okay, it's stuck again. It has some issue, I think. Uh, Copy and then here paste. So if I start from this index and then try to subtract 7 from it and see how much do I, if I make a prefix sum like this, 0 1 2 2 2 3 3, sorry, 3 4 4 5 5, I think that's right. 0 1 2 2 2 3 4 4 5 and 5. And if I subtract 7 from it, like I go back to, if I am in, I will check, I will start checking from this index, and I will try to check 7 index back and see the difference between them. So I am here in 0 1 2 3 4 3 4 5 6 7, 8, and 9. So if I subtract 7 from it, then I go to 2. So 1, 2, 3, 4, 5, 6, 7. So 9 minus, I will have to do current index minus k plus 1. So current index is 9. 9 minus 7 plus 1 is 3. So I will start. I will consider 3, or maybe not 3. Maybe k, because I am getting prefix sum here. So I will subtract this index and this I'll subtract the sum of this index uh, from this index. I'll subtract this sum. So that will be 5 minus 2, which is 3, and then I will again check from this till this. That will be 5 minus, not that, this 5 minus 1, that is 4. So 4 is not less than 3. I'll consider this one, right? 8 8 minus 8 minus 8 minus 5 minus 2 is 3. So I need to I need to maximize this color. Like I have 3 black colors in between them, and when I'm subtracting 1 from 5 for this index, 8th index, I'm going here. So this has 5 minus 1, which is 4 blacks. So this is better answer, 4 black. uh, and then if I try this that is again 4. So maximum I can get is 4 black. Maximum I have currently is 4 black. Then I will have to add 3 more, which is k minus the max black I have right now. uh, that's my answer. So that is 3. It should be 3. Okay, it's 3. So yeah, that's the idea. I'll not do Python, I'll do C++. So let's take a vector, integer, and let's say prefix sum vector. Let's name it prefix sum vector, uh, and initialize it with 0. Then I will do for character I in blocks. Then if I equals to black, then I will do prefix sum vector dot push back the previous the last. I named it too long, I think. I'll just do prefix sum. So prefix sum, I will add 1 with the current value and push it in the array, in the vector. Else I will just push the last mm, element without adding anything with it. So now I will have to start checking from the last index. For integer I equals to blocks dot size, or I can start from 0, and I is less than blocks dot size minus k, because I can if the size is, let's say here is 10. I think 1 2 3 9 index, so 10. I can go till this index. Like uh, with the first index I need 7 from this. So 3, let's mark it with red. 3 4 5 6 7, and then here, and then here, right? I mean, 3 4 5 6 7. Not necessarily. Yeah, that's it. And then here, sorry, here, and then here. So is it 1 2 3 4 5 6 7? So for k equals to 7, I can do this. I can do this. So 9 minus uh, 9 minus 7 had to be 2. So 1, 2, 3, 4, 5, 6. Okay, 6 and 7. So I had to do these actually. I had to do these. 1, 2, 3, 4, 5, 6, 7. Yeah, so something like that. So I can go to K. Sum of blocks is 10 minus 7. I get 3. So can I take 3? I'm trying to see if I can uh, make a length of 7 from starting from 3. So 1, 2, 3, 4, 5, 6, and 7. So yeah, I can go till this value. So sum of blocks minus K, and then I do I plus plus, and I just keep track of the minimum. I could just keep track of the maximum value. So or I can start it with 0, and here I can just check max equals to max of max comma prefix sum of prefix sum of uh, prefix sum of I plus k plus 1 minus prefix sum of uh, I, and then I'll just return it, return k minus mx. Let me see. Prefix sum. Okay, there's a missing bracket. It is wrong. Wait. So prefix sum of I plus k plus 1. Let's say starting from 0, I'm going to 0 plus 7 plus 1, which is 8. And I am subtracting the 0th index. Expected 3. So let me see it again. So let's take a smaller example of, let's say, WBB, and if I need 2 from it, 2k, if k equals to 2, then I will have to uh, I'll have to check the prefix sum will look like this: 0, 0, uh, 1 and 2. So for this index I will do, let's say, uh, so I'm starting from 0, I'm connecting this with it, and I'll subtract from this index, right? Because this is 0, 1, 2 and 3. So 0 plus I think that should be 0 plus I. Yes, let me submit. Yeah, 3 milliseconds. Okay, I thought it would be solved in 0 seconds, 0 milliseconds. Let me try it once again. 2 milliseconds. Okay, I don't know how else can we optimize it. Can we optimize it any further? Maybe we can check if mx equals to 0, then we'll just return not mx equals to 0. If mx equals to k, then we can return 0. Will it optimize it? Okay, there will be bracket need. I will need brackets. Hmm, let's see if that optimizes. Yeah, yeah, it did. It actually did because if I get a block, if I get the desired block without needing to make any white colored one to black, I can stop iterating and return zero from wherever I am. Uh, I'm a little sleepy today, so maybe I don't know if I could explain it well. But let me explain it once again what I'm doing here. So I'm taking a vector of integer named prefix sum, and I'm starting with 0 here. Then I'm iterating over the string that I'm given, and if the current string is if the current character is black, I am adding uh, 1 with the last value of prefix sum and pushing it back. So let's say for this, let me just erase all of this. So the prefix sum array, the vector that I am making here will look like this. I'm initializing with 0. Then uh, if it is white, if it is not black, which it means if it is white, then I am just keeping the uh, last element as it is and pushing it here. So there will be 0. And if it is black, I am adding 1 with the last value and pushing it here. So if it and it is again black, then I am adding 1 with the last value. Last value is 1, so I'm adding 1 more with it and pushing it here. And I'll not add anything and push the last value because it is white, and the same again. And I am adding 1 with the last value and pushing it again. So that's the idea, you get it. uh, so the vector looks like this. And then I'm here uh, keeping a max named variable to track the maximum amount of blacks I could get till now. So I'm iterating on the mm, string again. I'm starting from 0th index, and I'm trying to check the blocks of k length and try to see how much black colored element is already present here. So for example, I am starting from this index. So let's say if it is let's write the index of this 0 1 2 3 4 5 6 7 8 9 and 10. This is one element more. There is one element more. That is why it's the size has increased by 1. So I'm starting from 0th index and I'm adding 7 with it. So 0 plus 7 is basically 7. So which means you can see, as you can see, I'm trying to check how many blacks are in this block. So in this block I have 2 3 4 blacks, so I can get it by uh, subtracting 0 the first index and the from the last index, the element I have in the prefix vector. So in the last index I have 4 and in the first index I have 0, so I am subtracting 4 minus 0, which is 4. And then I will go to the second block, which will be this, and then I am subtracting 8. uh, I'm getting this, so I will subtract 4 minus 0, it's again 4. uh, and you can see that I have 1 2 3 4 blocks, 4 blacks here. Then I will take the this box or block, whatever, and there is 1 2 3 4 1 2 3 4 blocks, 4 black again. So I'll do this 5 minus 1, which is again 4. Then I'm taking the last block, which is basically 1 2 3. So here I have 3 blacks, so 3 blacks, right? 5 minus 2, which is 3. So 3 blacks. So 3 blacks is smaller than the maximum I got till now. So I'll not update the max variable with it. I am updating the max value of max value in that variable. Uh, so if I can take a block that has already the maximum amount of black in it, I'll need to make a less number of white characters to black. So that's how it works. So I have maximum of four blacks in the desired k length block. So I will need to do uh, only this amount of uh, coloring. I'll need to do this amount of white colored character to black. So and that's why I'm returning this, and this line I wrote just for optimization because I was getting 3 milliseconds and I didn't like it because I made a O of n solution. So I wanted to get 0 milliseconds. So I tried to optimize it by checking if I already got a block that has all black in it. Like the maximum that I got is already equals to k, then I'll just simply return 0 and stop iterating. So I hope I could explain it well. Have a good day, and it's a easy problem, so I'll say have a easy day. Have an easy day, everyone.